You may have inherited or found an interesting old lamp like this. Many can be found on popular internet auction sites or thrift stores. They suffer disuse because of old wiring, and when they do work, the light is harsh and not controllable. So these neat old lamps get sent to the attic or the back of the closet. We can modernize it without disturbing too much to bring it new life and make it a valuable item once again. We'll be using this smart lamp controller we optimized for projects like this. This will provide up to 5 amps for white LEDs and 1.4 amps for each RGB channel from 12 volts. The rotary encoder lets you control the white light so it works like a normal desk light, and by pressing the knob, the RGB color and brightness can be controlled. This smart lamp controller is available using the links below in the video description. It comes pre-programmed with this smart lamp controller application. Another Arduino or other type of controller can also be used together with the MOSFET transistors for the LEDs and a rotary encoder. We'll start at the bottom and see what's inside. It's made out of a solid piece of wood and carved out for the ballast and wires. You don't see this every day. Fluorescent lamps need a form of current limiting like LEDs do, and back in the day these weren't transistorized regulators, so inductor coils called ballasts were used. The wire is actually cloth covered, something to save. There's several wires going up each arm. We can use the old wires to pull in the new wires, so I'm not going to pull all of them out. For now I'll just put the removed parts in a box and keep it organized. Often with a project like this you may want to put everything aside for some weeks as you figure out some detail or need a part. So it's a good idea to find a good box that you can leave this in pieces and you won't lose any of the old or new parts. When the lamp is standing upright, the encoder will sit in the right hole, and the light from the status LED will shine through the left hole. Since most people are right-handed, this will be natural for them. I have some acrylic rod here that can be used as a light pipe, since the LED shining through may not be in the ideal position to see from above. We'll have to experiment to see what works. Next, we'll take the top apart so we can get all the old wires out of the way. Let's see what we have with all this out of the way. We can use the holes that the old switch used. These holes are 3/4 inch apart or 19 millimeters, and each one is 3/8 in diameter or 9.5 millimeters. It looks like the SLC board can be mounted directly. The board runs into the wood at the back, so a little carving will be needed. The SLC board has options to make mounting flexible. We'll mount the encoder on the back of the board and short some pads together. This tells the software to reverse the direction of the knob. There are also pads on the back of the board so additional status LEDs can be mounted. This is useful when the board can only be mounted in certain ways. We'll add a second status LED on the back and it will shine through the second hole. Every old lamp is different, so some experimenting is sometimes necessary. Now we'll build up a kit version of the SLC board. The kit version is sold without the through-hole components soldered, so you have many options to build your board. We'll solder the encoder on the back and short an option jumper so that the rotation is in the right direction. We'll add a second status LED and cut the shorting jumper to enable it. This puts the LED in series with the one on the other side. We'll solder the other parts to complete it. There's a cut trace that is under this paint right here, so let me scrape away some of this paint so that we can see it. The next version of these boards won't have the lettering in quite the same place. So the next thing is to cut this trace here, which is shorting out those two pads, like that. I'm doing this under a microscope, so it's a little different angle. And this is a 0603 sized LED that goes here. So next thing we'll do is to solder the LED in. I'll use a very fine tip. And first we'll just tin one of the pads on the right side. And then we'll get the LED on there. Now first we'll put a little bit of flux on that spot right there. You can see the LED is right there, little tiny speck. It's much better to do this with a microscope. So we just put this here and put this here. And then we'll turn it around so it's at a good angle. Perfect. The other thing we have to do is short the encoder option, which is these two pads right here. And that will tell the processor to reverse the direction of the encoder so that because it's upside down, it's going to go in the opposite directions. This is how the kit form of the board normally comes. We won't need the motion sensor in this case, so we'll take that away, put it in our bin. And the encoder normally would get mounted on the front like this. But the problem is that, as you can see, there's other parts in the way. I have experimented with mounting it with a plastic like this, and then that way you can see the inside of the board, or the top of the board. But for this build, we can also put the encoder on the back and reverse the direction. And so that way, with a flat back, all the components are on this side, which will be in that cutout in the wood. And then the LED is right here, and so that'll flash through the hole in the top of the cabinet. We'll start by tacking in the 6-pin connector for the LEDs. We'll put this in here. And solder this in Big Clive style. Although he probably wouldn't use a clamp. Then we'll tack in the power connector. So that goes in like that. Then we check to make sure that everything is straight. Now that's not straight, so just heat that up a little bit. Good enough. And next we'll install the encoder. And note there's 2 pins on one side and 3 pins on the other. So make sure that's seated in properly. And I just put a minimal amount of solder on the mounting pins, just enough to hold it. The next step is to clean it. So get this flux residue off of here with an anti-static brush and some isopropyl 99% alcohol. And I use a paper towel here just so I can fling all the flux residue onto it and it doesn't make the bench sticky. The next step is to put the LEDs on the lamp. And this is the piece of metal that was in the top of the lamp that the fluorescent lights were attached to. And I just noticed there's an interesting sticker, if I can get it in focus, Van Dyke, Chicago. Well, the first thing we want to do is wipe this down with alcohol because we want the LED strips to stick to it well. So get some isopropanol 99%. You see there's dust here from the fluorescent lights, would always leave a dusty mess. I think we'll put 2 strips down here to mimic the 2 LEDs or 2 fluorescent lights that used to be there. Careful not to rub on the sticker, you want to preserve that. I made another lamp with 1 strip of LEDs and I think it could be a little bit brighter, so. But there's plenty of room there to put several strips, and there could be extra white strips if you want a lot of white light. There's a lot of options, so 2 strips should do it for a starter anyway. So we'll just cut a couple of pieces and see how long. That's perfect. We'll cut it right there. I've learned the hard way that you don't want to cut these things except where they show you to cut it. Catastrophic failure. We'll cut it there. The next step is to cut the wire, and I got some 22 gauge. I got white and gray. I'm going to use these up because these tend not to get used as much as the red and gray. So we just cut one to, and you always got to overestimate. And I guess they can all go down to one pipe, and they got to go over to there. Alright, so that's the length. Just to double check. Hold it in where it's going to go. And yeah, that's probably 6 inches or a foot extra. And again, we'll use these wires to pull in the new ones. And one gray. You could probably get away with 24 gauge. It's thinner, but it's nice to have some extra mechanical strength in the thicker wire. So you got plus 12 RGBW. So I got to figure out, plan this a little bit so you know a good place to solder it. So we'll put this here and use this and this. I like to alternate use every other pad so the soldering isn't so close. And then the wires can go down that hole. So we just skip one and solder to the next two. First thing with these things is you want to scrape, there's silk screen on here, and you want to scrape a bit of the copper so that the flux will have a chance to get to the actual metal. So we'll do every other one, 1, 3, and 5, and then over here we'll do the 2 and 4. I'm going to hit them with flux. Then we'll tin those real quick. Clean the tip. There's flux in the solder, but putting flux on extra just gives the flux an extra chance to get to the metal before it gets oxidized. Now we'll get the wires ready. I'm going to strip off about 2 millimeters or so. A sharp right angle in that to get it let it lay down. Oh, forgot the flux. Flux, 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 flux on there. All right, now we can reflow. And then putting them at a right angle so that they're out of the way of the LEDs. We'll need to connect the two LED strips together. For this, I'll use bare copper wire and insulate it with Kynar tape. And just as with the long wires, I'll use every other pad to make soldering easier. Now we'll lay down the strips and see how they fit in the fixture and mark where the connection point will be so that we can stick them down. I like using bare wire for joining LED strips together. It's faster, not having to strip the wires, and it's also easier not having the insulation in the way. The wires do have to be secured and insulated though, so I use Kynar tape for that. It's best to put a kink in the wires to relieve any stress from thermal expansion. You have to be careful to protect the wires. The cutouts in this metal are stamped and there's a sharp edge, so I'll file that down. I have some fiberglass sleeving from an old fixture, so I'll use that for extra protection. I'll twist the wires together just to make things a little neater. And then we strip each one about 2 millimeters. Now I use one of these C-grid blocks to push the wires into, and the way it's wired is the first pin is 12 volts, then RGB, and then 12 volts again, and then the white. And that's actually marked here on the back. So it's plus 12, RGB, plus 12, and white. So we skip that one pin. So these have a pin 1 marker right here. I'll take that positive, and that clicks in. And now we'll get the power supply and check each one to see which color is which LED. So we got the power supply on, and that's red. So that one will go into the first. And just leave that in loose, just to hold it for now. That's blue. We want green. So that's green, that's the next one. That's blue. And that's going to be white. We just test it. Yep. So now they're all in. Use a pair of needle nose to help these in till they click, and you can see a little latch there. This goes into an AC input, so it actually doesn't matter which, you don't have to worry about reverse polarity. So we plug this in, and we can test it. And now we can start mounting it in the base. The next thing we need is power. So I got one of these barrel connectors, and I'm going to hook it up, but I'm going to put the wires as flat as I can because there's very little space in there, and you don't want it to short out, of course. I'm going to take care of mounting that power connector first to get that out of the way. The connections are well below the surface of the wood, so that'll be safe. I just put a little hot glue in here, that way it's not too hard to get it out if I want to change it. If I was selling this, I might drill another hole or do something different, but I don't really mind it sticking out like that, and it keeps it away from the electronics. I actually don't know how I'm going to mount this yet. I don't want to put screws in this way because it's very thin on to the top,
And also when you push down, I don't want to just hot glue it, because when you're pushing on the button, you're pushing down on the circuit board. So it needs a good solid support from the bottom. So I'll figure that out. And the other problem is that this LED is a ½ inch away from the center of this, but these holes are 3/4 inches apart. So this LED is actually pointing about here. So what I'm going to do is get a piece of light pipe and make a light pipe to go over to this place. Maybe just a straight piece is enough to catch it, I don't know. So that's the next experiment. One way to solve the light problem is to take a piece of this, and this is a little smaller than this hole, but I could angle it this way, sand it flat on this side, and then just cut it and hot glue it in so it sits right above this LED. So the light from this LED will travel through the pipe, and then you'll see it from the top. I sanded this at an angle and took a little off the back, so now this sits, you can feel it on the top, it feels pretty flat. I set this to 5 millimeters. And there's a final piece. It's cut with a hacksaw. And I think what I can do is just tack that in with a little hot glue just to hold it. Ow, 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 ow. Hot glue is hot. I'm just going to hold this thing manually up into place. Let me move the camera, and we'll try it now. Okay, if you look down here, you can see the light flashing. So it's working, I just need to mount it. Now to mount the board, we use these nylon 440 standoffs, and I've mounted 2 of them here. And what I'm going to try to do is just hot glue this in, and then add some more hot glue. If it's going to be more permanent, you probably want to use epoxy or something. So I found a sleeve that goes easily over the encoder, and I wrapped some tape on it thick enough to fit in that hole. And so I just push this in here, and when it's glued in, it'll sit flush and I can pull it out the top. It's been several minutes, so I want to make sure that the hot glue is definitely cooled down. I tried this before, and it wasn't too hard to pull those standoffs from the wood. So I need to add some reinforcing hot glue. More hot snot. Doing this on camera is difficult, but just give it more surface area to the wood. And it should be easy to peel off if I want to redo it later. This is kind of experimental, so. The lamp is normally in mode 1, which controls the white light when you turn the knob. Just like any desk lamp, you'd expect the white light to work. When you push the knob once and you see 2 flashes, now it's in mode 2, so it will change the color and just leave the color like that. When you push it a 3rd time, you can change the brightness of the color. And when you hold it down, 2 flashes, it goes into rainbow mode. And it will use the settings that were previously set. Now, if you press and hold it for 1 long flash, it just shuts off.
I hope you find this video useful and entertaining. Watch for upcoming videos on putting the smart lamp controller to other uses in the real world. The smart lamp controller is available through the links below in the video description. We offer engineering services and are able to design and produce custom units if you have special requirements. Our contact information is below. Please consider leaving feedback in the comments section, since this will help us make future videos better.